Okay, today we're going to learn how to manipulate equations. When you get to Algebra 2, you're going to have equations with a whole lot of different variables in them, and you're going to always want to isolate one variable. So we're going to learn how to do that when we have various variables within an equation. So in this equation, we want to go ahead and solve for x. And this equation is pretty basic. We expect you guys to be able to do something like this, and if you don't remember how to do this, we'll go ahead and show you right now. So I want to solve for x. X is in the numerator. First thing you have to do is to get rid of the denominator. So since s is in the denominator, in order to cancel him out, I need to multiply both the left and the right side of the equation by s. Okay, now when you multiply it, all of this times s, and there's only one thing over here, but it's everything on the other side times s. When you do the inverse function, so the opposite of dividing is multiplying, they cancel. So now on the right side, I have s times z is equal to y minus x. So here, I need to get rid of the y, so we're going to subtract y to both sides. Remember, what you do to one side, you do to the other side. So now we have s times z minus y, and here's the number one mistake that a lot of students do. They forget, or I think they just drop this negative. So we have a negative x still on the right-hand side. Now x is not quite by himself, there's this negative 1 in front of him, so we need to divide both sides by negative 1. Now when you divide or multiply, everything has to be divided or multiplied by that number. So in this case, we're dividing by negative 1, so everything on the left side is going to be divided by negative 1. Now look at the coefficient in front of each of your variables. Here, this has a coefficient of 1. So if I did 1 divided by negative 1, this now becomes a negative 1 s times z. So I'm going to leave out the 1. But you can't forget that just because there's not a number here, it doesn't mean it's 0. It just means that we have a 1. In front of this y, we have a negative 1 as well. Negative 1 divided by a negative 1 is a positive 1, so that ends up being plus 1y. And this equals x. So here, this is our final answer. We've solved for x, which is negative s times z plus y. Let's go ahead and try one that's a little more complicated. Here we're going to solve for x. Now this right here is the equation of a circle. You will see this equation next year in Algebra 2 when you study conics. So here, we need to get x by himself. So first, let's go ahead and move everything else we can, and then we'll worry about this right here. Notice how x is in the parentheses. It is being squared, so we will have to cancel that at some point. So I'm going to first start off by subtracting all of this. Now, since this is in parentheses, it's one thing. I'm going to subtract y minus k squared. It was a positive, so the opposite of a positive is a negative, so we're subtracting. What I do to one side, I have to do to the other side. So y minus k squared. These go away. So on the left side, I now have x minus h squared equals r squared minus y minus k squared. So I've subtracted this and I moved it over to the right side. Now here, x is inside of the parentheses, which is being squared. In order to cancel the squared, we must do the inverse function, or the opposite of a square. The opposite of a square is to square root. So if I square root both sides, this square root will cancel out with the square. And what we will have left on the left side is x minus h. Now, there's no longer an exponent up here, so we no longer need those parentheses, and we can go ahead and get rid of those. Now, on the right side, students have a tendency of thinking that these squareds will also cancel with this square root. That is not true. If there is a plus or a minus sign inside of that, it will not cancel. Now, notice over here there is a minus sign, but this is one thing, okay? And it was inside of the parentheses. Here we're dealing with two things, okay? So you've got more than one thing in the square root. This counts as one because it's in the parentheses. The r squared is another thing. So this minus sign is keeping us from canceling the square root with the squared. So over here I have the square root of r squared minus y minus k squared. So we're almost done. Now I just have to add h so that the h can cancel here. What I do to one side, I have to do to the other side. So these cancel, and I'm left with x is equal to the square root of r squared minus y minus k squared plus h. The h is outside of the square root. Square root ends here, so be very careful on how long you extend the square root symbol. Alright, so let's go ahead and solve for p here. Notice that p is inside of the square root, so we're going to have to cancel that at some point. But let's go ahead and move everything we can over to the other side and get the square root by himself. So I have z times the square root of pq over n. Since this is multiplying, these are two terms that are being multiplying, in order for me to cancel the z and move them over to the left is to do the inverse or the opposite. So we're going to divide both sides by z. So these right here will cancel, they multiply out. So I'm left with m divided by z is equal to the square root of pq divided by n. So now p is in the square root. I can't just pull them out. So I'm going to need to cancel out this square root symbol here. In order to cancel the square root symbol, just like we did on the previous problem, the square root and the squared cancel. So I'm going to square this side, and I'm going to square the other side as well. As long as I do the same thing to both sides, this equation will remain equal. So now on the left side, I have m squared over z squared. And on the right side, the square root and the squared cancel each other. So I'm left with p times q divided by n. So now I just have to get rid of the n and the q. Well, first I'm going to get rid of the denominator. The denominator is dividing, so I'm going to multiply both sides by n in order for that n to cancel now. Remember, everything's got to get multiplied here. This cancels because we did the inverse. Right here, just like we had with the rules of multiplying fractions, this is technically n over 1. So we're going to do n times m squared and 1 times z. So I'm going to go ahead and continue this work up here. So now I have m squared times n all over z squared. And on the right side, I have p times q. Now p and q are being multiplied. So in order to get rid of the multiplication, we are going to divide so that we can get rid of the q. And over here, I'm going to divide as well. I know this looks a little bit weird. You have a fraction and then dividing by something else. Not a problem. We'll deal with that in a minute. So we know that these right here divide out to be 1. On the right side, we have p. So this right here, we have a fraction divided by a fraction. If you remember, when you're dividing, you're just multiplying by the reciprocal. So we have m squared times n over z. And this q, when it's underneath, remember q over 1, that's our fraction. So if I divide by this fraction, I'm multiplying by the reciprocal, 1 over q. So now we can go ahead and multiply these together and get m squared times n all over z times q. And this equals p. So we are done. So as you can see, manipulating fractions takes a little bit of work because you've got a lot of variables, but you just got to take one step at a time and figure out what is trapping your variable, get it by himself, do what you need to do to get everything onto the other side. So now it's your turn. Go ahead and solve for b in this equation. You want to move everything else to the right side and get b all by himself. Bring this problem to class and we'll discuss and see if you did it correct.